right, guys, let's talk about factors and let's review what we've been discussing in class about factors. So, first, let's review what a factor actually is. Factors are the numbers that can be multiplied together to arrive at any certain product. So, for example, if we think about the number 12, there are a lot of numbers we can multiply together to arrive at the number 12. We can, if you remember back to number decomposition, we could multiply 12 by 1 and we would get 12. We could also multiply 3 by 4, and we could multiply 6 and 2. So the language we would use to describe what this relationship is we would call all of these numbers underlined in red factors of 12. On the flip side, we would call 12 a multiple of all of those numbers that you see down here. So just to prove it to you, let me just show you on a hundreds chart like we've seen in class what that looks like. So if we think about the number 12 to start, let's highlight all of the factors of 12 leading up to the number 12. So 12 is where I'm going to land in the end. So I can multiply 1 times 12, 2 times 6, 3 times 4, 4 times 3, 5 doesn't work, 6 times 2, no 7, no 8, no 9, no 10 or 11. So all of those numbers boxed in blue are factors of 12. And actually 12 is considered a factor of itself as well, because like we saw on that first slide, 12 can be broken down into 1 and 12. So don't forget those two are definitely important. So again, if you were to really think about this, if you counted by ones, you would definitely land on 12 if you counted by ones, because you would say 1, 2, 3, 4, and you'd keep going, and you would definitely land on 12 counting by ones. So it's definitely a factor. If you counted by twos, you would also land on 12. 2, 4, 6, 8, 10, 12. So 2 is definitely a factor. If you counted by threes, you would land on 12. 3, 6, 9, 12. So 3 is a factor. If you counted by 4, you would also land on 12. 4, 8, 12 would be our third one. So 4 is definitely a factor, and certainly if you counted by sixes, you might guess that the second number you hit is 12, so 6 is a factor. So that's why we say that 12 is a multiple of all those numbers. 12 is a multiple of 1 because when I count by ones, I arrive at 12. It's a multiple of 2 because when I count by twos, I arrive at 12, and so on and so forth. 12 is a multiple of 1, 2, 3, 4, and 6. And 1, 2, 3, 4, and 6 are factors of 12. So the bigger number we refer to as a multiple, and the little guys that number is divisible by, we call those the factors. So that is our review of what factors are. So let's go back, and now let's talk about why they're so important and what we can do with them. So before we move on, I do want to bring up, there are special numbers in our number system that are special for the reason of only having 2 factors. So when you think about it, when we looked at 12, 12 could be broken down in a lot of different ways. But one of the ways was 1 times 12. Sometimes there are numbers out there that will only break down one way, and that will be 1 multiplied by itself. 7 is one of those special numbers. 13 is one of those special numbers. 2 is one of those special numbers. And we call these special numbers prime. They are prime numbers because there is absolutely no other way to decompose them except for to break them into one and themselves. All the other numbers in the number system that can be broken down in a variety of ways, like 12, we call those composite. It kind of reminds me of vowels and consonants. There's only a few vowels, and we call everything else a consonant. In this case, there are prime numbers that we talk about, and all the other numbers are composite. Although technically there are an infinite number of prime numbers because numbers go on forever and ever. So what can we do with our knowledge of these factors? So let's first see if we can find all of the factors of a number. let's look at 24. So you should have your Review Center notebook opened up and pasted in and ready to go. And we are going to find all of the factors of 24. Now, before we do that, let me just back it up really quick to 12 again. When we broke up 12, we said, okay, we could do 1 and 12, we could do 3 and 4, and we could do 2 and 6, right? And sometimes if you're listing it out this way with our decomposition trees, it could get really confusing and hard to organize. So an easier way to organize is that what we call the factor rainbow from class, which is a little bit easier. You take your number that you're thinking about, the one that will be a multiple of all the others, put it in a box, and then you give yourself space and start listing out the numbers that connect with each other. So 1 times 12, which came from this tree here, I'm going to put them on the outside of my rainbow because I'm going to work my way in. 1 and 12 go together to make 12. Then I think to myself, okay, let me think about 2. Is 12 divisible by 2, which would then mean it's a factor? It is, because 12 divided by 2 is 6. 12 is a multiple of both 2 and 6, and 12 divides by both 2 and 6. So those are going to be factors that I list down there as well, and they will be linked up together. The next number, if I'm counting in order, I tried 1, I tried 2. Let me think about 3. Is 12 divisible by 3? Yes, it is. As a matter of fact, 3 times 4 is 12. And both of those would then be factors of 12. And then the next number that I would try is 4, but I already tried 4. It's right there. So I stick my comma in the middle, and there are all 6 of the factors of 12. And that way is a little bit more organized and helps me think faster than having to list them out this way. So let's go back to trying 24, and let's use the factor rainbow to find all the factors of 24. We're going to start with 1 and 24 in your notebook. Press pause and try to find the rest. Go ahead. Okay, let's see how you did. So, the next number that I would want to try is 2. I know that 24 is divisible by 2 because 2 is an even number. So 2 times 12 is 24. If I didn't know that fact, I could always check it on the bottom. Since I'm really confident that 24 is divisible by 2, I could just down here on the side do some quick division to determine that that's 12 if I didn't know the fact quick enough. That will help me get the other side of my rainbow. The next number I will try, of course, is 3. I do know 24 divides by 3 because I know 8 times 3 is 24. But again, if I wasn't sure, I could have checked it down here. I would have realized that this must be a math fact because I can't break down my 10s and my 1s. So I would have thought to myself, okay, now that I figured out this math fact, does this look like something I know? And it does. I know an 8 goes in that number bond there. I could also count by 3s to see will I ever land on 24 if I wasn't sure. 3, 6, 9, 12, 3, 6, 9, 12, 15, 18, 21, oh, 24, yes, I do end up landing on 24 when I count by 3s, which means 24 is a multiple of 3, which means that 24 is divisible by 3, and so it is a factor with 8. Because it's the 8th one. 1, 2, 3, 4, 5, 6, 7, 8. So these that I've drawn down here are strategies you can use if you're not sure if a factor works. Next, I will try 4. I know 24 divides by 4 because 6 times 4 is 24. And the last number left that comes between 4 and 6 is 5, and 24 is definitely not divisible by 5. I would end up with a remainder because 24 does not end in 5 or 0. It will not divide evenly into 5 groups. And so this is our whole factor rainbow for 24, which means that I've discovered there are 1, 2, 3, 4, 5, 6, 7, 8 factors of 24. And of course 24 would be a multiple of all those numbers I see there too. All right, let's try another one. I want you to try 32. Press pause and see if you can find all the factors of 32. Go ahead. All right, let's see how you did. First, I will start with 1 times 32, of course. I will check 2, and I know that works because 32 is even. I'm not sure what 32 divided by 2 is. Let me just try it over here. 3 10s broken into 2 groups. It'd be 1 in each group. I'd have a 10 left, regroup it. Now there's 12 ones. 12 divided by 2 is 6. Okay, so 16. Perfect. 3 does not work. 4 does work. I know 4 works because 4 times 8 is 32. In case you're wondering how I knew 3 didn't work, I know 3 doesn't work just from experience, but if I didn't, I would have tried 3 on the side, and when I try it, I would have found that I cannot divide 2 ones evenly into 3 groups, which means there would be no ones in my group, and I'd end up with a remainder. Remember, when you have remainders, that means that the number is not divisible, so that means that 3 can't be a factor. It means that if I counted by 3s, I would never land on 32 on my hundreds chart, ever. So then I would think about 6. Does 6 work? 6 I know does not work. 7 does not work. And then the next number is 8, which I already have up here. So there's only 6 factors. And I finished. So the last thing that we're going to talk about with factors, and again, if you need to watch any of that part of the video again, please do. The last thing we want to talk about is the greatest common factor. So the greatest common factor is really, really important because this has to do with the number that 2 numbers are divisible by, that they both are divisible by the same number, and it's the biggest one they're both divisible by. So just before we actually talk about the greatest common factor, let's just back it up to regular common factors first. Let's think about the number 8 and the number 12. So before we break these up, let me show you on a hundreds chart all of the factors of these 2 numbers. So let's do factors of 8 in green. So 1 is a factor of 8, so is 2, so is 4, so is 8. If I count by 1s, I will land on 8. If I count by 2s, I will land on 8. If I count by 4s, I will land on 8. And certainly if I count by 8s, the very first one will be 8. So there are the 4 factors of 8 right there. Those are the only factors of 8. If I did my rainbow, these guys would match up. Okay, now let's do the factors of 12 in red. So definitely if I count by 1s, I will land on 12, 2s, 3s, 4s, 6s, and 12s. These are all the factors of 12. 1, 2, 3, 4, 6, and 12. My rainbow, they would all match up. Okay, so which of these are common? Well, on the 100 chart, where you see circles and boxes, those are the common factors. So the common factors are 1, 2, and 4. Those are the only factors that they have in common, meaning that I can divide 12 and 8 as a team together by 1, and I would get 8 and 12. I could divide them both by 2, and I would get 4 and 6. Or I can divide them both by 4, and I would get 2 and 3. So this is how we arrive at common factors. And we see that they match up, of course, when I look at them on the rainbows as well. So then we talk about the greatest common factor. The greatest common factor is the greatest number that they both have in common, which is 4. And the reason that number is so important is because it can be applied to a lot of different math situations. So let me show you. We know already from what we just did that the GCF of 8 and 12 is 4. So let's see why that matters. Remember when we talked about the ladder in class as a way to find the greatest common factor? So literally, this is like an upside down division bar. Think of it like that. Let's say that I want to make vases of flowers. And let's say I have 8 white flowers that I want to stick in vases. And I have 12 red flowers. And I want to make as many vases as I possibly can for a party, but they all have to have the same number of white and red flowers in them. So because both of these numbers divide by 4, I can divide both of them by 4, and 8 divided by 4 is 2, and 12 divided by 4 is 3. And this actually would help me with this problem. This would suggest that I can take my 8 white flowers and my 12 red flowers, and I can build 4 vases, because I can divide those into 4 evenly. 8 divides into 4 vases evenly, and so does 12. And I can put 2 whites in each. That is the smallest amount of whites I can put in each of them so that they're all even. Couldn't do 3 because I wouldn't get as many. And then it means that I can put 3 reds in each vase. So now all those vases have the same flowers in them. I've created 4, and there are 2 whites in each and 3 reds in each. So using that greatest common factor really helped me to solve this, because I needed to know how many vases I could use if I wanted the maximum amount. I could have, just to show you, I'm going to leave that picture up. I could have said to myself, if I didn't know that, I could have been like, well, I know both of these divide by 2. So 8 divided by 2 is 4, and 12 divided by 2 is 6. And I could have put 4 whites in each and 6 reds in each. But then I only would have gotten 2 vases, and I could have split them up even more. These can be split up again into 2 more vases, and I could have only 2 whites in each and 3 reds in each. And that's why when we told you we do the ladder, if you multiply these numbers together, you will get the greatest common factor, because it's the biggest number you can divide them both by. So you can solve problems like this when you're trying to divide things up and you have 2 totally different numbers you're trying to divide things up with, and you need the same amount of stuff in each thing you're talking about. So this is how we could kind of apply greatest common factor. So now let's have you practice. Try to find the greatest common factor of 16 and 48. If you want to use a hundreds chart to do this, you may. Press pause and give it a shot. Okay, so I chose to use the ladder for this, and I'm asking myself, okay, all the numbers I can count by to arrive at 16, and all the numbers I can count by to arrive at 48, what's the biggest one that I can count by to arrive at both of those numbers? Well, I'm noticing that both of them are even, so they both divide by 2, so I'm going to start there. 16 divided by 2 is 8, and 48 divided by 2 is 24. But now when I'm looking at 8 and 24, those are divisible as well. I can divide by 2 again. So if you divide by 2 again, you will arrive at 4 and 12. But now I'm looking and I'm thinking, I can divide by 2 again, but actually I say I can divide by 4 also. If I divide by 4, I will arrive at 1 and 3. I cannot divide 1 and 3 any further. So that means that I could count by 2s to arrive at these numbers. I could count by 4s to arrive at these numbers, because I see that those are factors I used over here. But the biggest factor that they all have in common would be 2 times 2, which is 4, times 4 again, which is 16. I could have actually completed this ladder in one step using the number 16, and I would have arrived at 1 and 3, because 16 times 3 is 48. And so 16 would be the GCF of these 2 numbers. You may go and try a practice station. I wish you the best. If you need to rewatch the video, you may do so.